Okay, hey everyone. In this video we are going to go over a nodal analysis problem where we solve for V naught, and in a previous example we already solved this circuit, but we used mesh analysis, which is over here, so you can go and look at that video if you're interested in that. We're going to solve it the other way now using nodal analysis. So for nodal analysis, let's identify our nodes. So here's one. Here's another one. Here's another one. So there are three nodes. So notice when you're doing this on an exam, there are three nodes versus two meshes. So on an exam, you're probably going to want to do mesh analysis since there are fewer meshes, meaning you'll have fewer equations to work with ultimately. It'll speed things up slightly, but to do things a long way will help us understand stuff a little better. So we have V naught so far, V1 and V2. So again, what I really did just now was I labeled each of these nodes. And the next thing I'm going to do is assign the current directions with respect to each of these nodes. So they're all arbitrary as long as I'm consistent. So for example, if I say going into this node, with respect to this branch here, its current is going into node V1, well, it must also emerge from V1 because it's the same branch. So I just have to be consistent. So actually, let me delete this now. And again, you could have solved it like that, but just to make things more fun and to illustrate a point, this is valid as well. The current directions are arbitrary. You can define them however you like, as long as you're consistent. So here I'm saying it goes to the left. Well, and down here it must be going downward, because it's the same branch. Okay, and now you assign directions for everything else. So let's go down there, let's go like that, and let's go like that. So these two, this is really a pair here, right? Because it's the same branch. So here it's saying from left to right. So therefore, once it gets to this corner here, it must start going downward. So we have to be consistent there. And again, it's arbitrary. You could have made it go the other direction too if you wanted to. Okay, so let's continue. Notice that we actually have supernodes, the simple version. We have voltage sources. And the idea is these voltage sources, one side of them is tied to ground. So I know I'm drawing in multiple ground symbols, but that's legal because they're all touching the same wire. It's just saying that this bottom section of wire here, they're all 0 volts with respect to our analysis. And the way that the voltages work, hang on a second, delete that. The way that the voltages work is it's saying that if you start from here, for example, and you work your way toward V1, you're going to experience a voltage gain of 60 volts. Similarly, if we look at the other side here, let's delete that. If you start from here, which is 0, you work your way toward there, you're going to experience a voltage decrease of 24. And I say decrease because you can see the negative sign is on the top. That's how you read it, whereas here the plus sign was on the top. So now I grab the negative sign and I also grab the magnitude of 24. So the idea is, okay, well, what this is saying is that V1 is equal to ground. Remember, this is ground. Plus 60. And remember, ground is equal to 0 for the purposes of our analyses. So V1 is equal to 60. And V2 is equal to, same thing, ground, minus 24, which should be equal to negative 24. So right away, we've actually solved two of our nodes already. We don't have to actually do the KCL equations at V1 and V2 because you already know the voltages at those nodes. You only have to do KCL at V naught, so let's take care of that. So for our third and final equation, for V naught, we have a bunch of currents leaving the node V naught. So that means on one side of the KCL equation we have 0. And now we tally up or add up all the currents that leave. So let's start with the 1 through the 12 ohm resistor. That'll be V naught minus V1, which we found was 60, divided by 12. The next current, let's do this one, 10 ohm resistor. So from V naught to ground through the 10 ohm resistor. So V naught minus 0 over 10. And then the next one is through the 6 ohm resistor. So from V naught to V2, so from V naught to V2, think of that minus sign as an arrow from V naught toward V2. Just be consistent with the arrow sign. through the 6 ohm resistor. So now just divide that by 6. So now we have our third equation, or really it's just one equation because we kind of already solved these guys. So we have one equation, one unknown. You can solve for V naught from here. You can do that by hand or use algebra in MATLAB or Python, your program of choice. But yeah, this turned out to be pretty simple, even though there were 3 nodes, which is more than 2 meshes. And the reason why it turned out to be simple is because we have these super nodes here. It helps to simplify our expressions. All right, thanks.